hand out a sheet for chapter 11. We're going to cover 3 of these today, and then we'll cover functional groups, I think, next. So this, you can't use this on your note on the test, but you can put this on your note card, or you can put the parts that you need on your sheet. All right, and so this is a review. We're just focusing on organic molecules. So we've drawn Lewis structures before. We've talked about bond angles, but now we're specifically talking about bond angles in organic molecules. And then we'll talk about chemical groups. All right, so we classify an organic molecule as something that contains carbon. If it has carbon, it's going to be organic. Generally, organic compounds are molecular, so they have covalent bonds. The atoms are sharing electrons, not stealing electrons. So a covalent bond means that electrons are shared. They're not stolen like in ionic bonds. All hydrocarbons are organic compounds. Hydrocarbons only have hydrogen and carbon. If it has oxygen, that's not considered hydrocarbon. So one of your homework questions will ask you, is it organic? Does it have carbon? Yes, it's organic. If it doesn't have carbon, then it's not organic. It would be inorganic. It will also ask you if it's a hydrocarbon. If it has only hydrogen and carbon, then that's a hydrocarbon. If it has anything else besides hydrogen and carbon, then it's not a hydrocarbon. So we're not going to do a practice problem. I think you guys can do this one in your labs. Okay, so then you have this chart on your sheet, the note sheet that I handed out. So we have these different atoms, and we've talked about this before. We have these different atoms, they have different numbers of valence electrons, and that decides how many bonds they want to form. So in this section, if you can remember, hydrogen forms 1 bond, carbon forms 2 bonds, or 4 bonds, excuse me. Nitrogen forms 3 bonds, oxygen forms 2 bonds, and if it's a halogen, so that's fluorine, chlorine, bromine, or iodine, they only form 1 bond. So if you can remember that, that's going to be really useful for when you are either drawing or evaluating Lewis structures. So then you can look at it and say, oh, well, carbon doesn't have 4 bonds, so this must be wrong. I need to add another bond. Okay. So let's go through each of them just really quick. So hydrogen wants to form 1 bond. It has 0 lone pairs. Carbon forms 4 bonds. It will have 0 lone pairs. Nitrogen wants to form 3 bonds. It has 1 lone pair. Pretty soon we're going to stop drawing the lone pairs. So even if it doesn't have a lone pair drawn, then you still have to remember, nitrogen has 1 lone pair, it has 3 bonds. Okay, so watch for that. Oxygen has 2 lone pairs and 2 bonds. Halogens have 3 lone pairs and 1 bond. Yes?
Does carbon ever do like a double bond for our
Yes. Yes, all the time, yes. Yes, so that's These bonds could either be together, you could have a triple bond. Quadruple bond is very kind of weird, so we probably won't see that. But yes, if the carbon only has 3 bonds, then you probably have to add a double bond onto it. Okay. All right, so this is some tips for drawing a Lewis structure of a carbon chain, organic compound. So first you're going to draw the carbon chain. So look at the formula, figure out how many carbons it has, draw that number of carbons. And then go ahead and add any heteroatom. So we call anything that's not carbon and hydrogen a heteroatom. So on our little diagram, nitrogen would be a heteroatom, oxygen would be a heteroatom, and then the halogens would also be heteroatoms. So then you put those heteroatoms into your carbon chain. Then you're going to look at how many hydrogens you have and go ahead and add those onto your structure. One tip for adding hydrogens is usually, not always, usually or often, organic molecules like to be symmetrical. So you're going to put, if you put a hydrogen on this side, put a hydrogen on the other side. And then you're going to go back and check. Make sure carbon has 4 bonds. You might have to add a double bond. Make sure oxygen has 2 bonds. You might have to add a double bond. Make sure the heteroatoms only has 1 bond. Make sure hydrogen only has 1 bond. If you add extra bonds, then that's going to not make sense. So we're using our diagram as a pattern to follow. We're looking for trends. So carbon always has 4 bonds. Oxygen always has 2. Okay, so here are some tips to while you're drawing. So halogens only form 1 bond, so they're not going to be in the middle of the chain. Okay, because they only have 1 arm to bond, so they're going to either be at the end or coming off of one of the carbon chains. So that usually we just put them at the end if we don't know the structure. Oxygens form 2 bonds. So we have 3 different ways that an oxygen could show up. It could show up in the middle. It could grab a carbon on both sides. It could show up on the end with a hydrogen. So if it's at the end with a hydrogen, we call that a hydroxy group, and we'll talk about that in a minute. If it has a carbon on both sides, that's called an ether group. If it's double bonded to a carbon in the middle of the chain, that would be called a carbonyl group. So carbon can show up 3 different ways in this structure. Nitrogen is going to form 3 bonds. So it could be in the carbon chain, it could bond to carbon on both sides, or it could do this amino group. It could be at the end and have a hydrogen, 2 hydrogens to complete its octet. So these are some patterns to watch for as you're drawing these molecules. And we're gonna talk about page groups and
Are you still on track?
okay, so go ahead and try this one. Go ahead and try to draw this molecule following those guidelines.
So this is what we like to call hydrocarbons. Electronics. Oh, I can. Let me look at those first. Give it 2 carbon. That has to be like double one carbon. Yeah. No, not good. Yeah. Is it triple? I thought it was double. Oh, it's triple.
Okay, so it sounds like you guys figured it out back there. What do you have to do?
So you guys get all the carbons.
Sorry?
Where's the other carbons next?
Straight? So draw the carbons. We got our carbon chain.
And then the H on the H.
Okay, H is on the outside. We're gonna do it symmetrically if we don't have enough hydrogens to fill everything up.
And satisfy the octets.
Okay, so hydrogen's satisfied, it just has 1 bond. Carbon's not satisfied, what do you have to do?
Here's 2 more lines.
Okay, good. So now carbon has 1, 2, 3, 4. Carbon has 1, 2, 3, 4 bonds. And that will be our molecule. Okay, very good. The next part is we're going back to the shapes of molecules. So we have the bond angle chart. So in our chart, it tells us the number of groups of electrons. So remember, we pick an atom, count how many electron groups. Electron groups can be lone pairs, electron groups can be bonds. And then, depending on how many electron groups are around the central atom, that will tell us the shape. Do you remember this from chapter 4? It's been a while. Then today we care about the bond angle. Okay, that affects the shape of the molecule and the carbon chain. So if we just have two groups around an atom, so this carbon or this carbon, each of these we have two parts, two electron groups. We have a bond on this side and a triple bond on the other side. So the furthest those can move away from each other is in a linear shape, or we call that that is 180 degrees. Okay. How many of you have been working on trigonometry in math? Okay, so you're going to be super good at angles. Okay.
We're gonna be really good on it.
All right, the next one is if it has three groups. So if we look at either of these carbons, so there's looking at this carbon, it has one bond, two bonds, three bonds. We do 360 divided by 3. That gives us 120. That's the furthest those electron groups can be from each other. 120. Okay, this one is a little bit tricky, but if you have a carbon, so it looks like this. If we have a carbon with 4 groups around it, it's not going to be planar. So if it was planar, then those bonds would be 90 degrees from each other. But they can spread out even further. They can get to 109.5 if they spread out in 3D shape and form a tetrahedral. So they're saying the bond angle from a hydrogen to another hydrogen, so this angle here, would be 109.5. Does that make sense? Okay. So those are ones that you have to remember, or you have to write at least part of this on your periodic table. Or not your periodic table, your note card. Does that make sense? So you either have to remember if I have 2 electron groups, that's 180 degrees. If I have 3 electron groups, that's 120. If I have 4 electron groups, that's 109.5. Or you have to write that on your note card. Or chapter 11. Okay, I just wanted to point out, have you seen this kind of drawing before where they have like this is called the wedge and the dash? Have you seen that? Okay, so what they're trying to do is they're trying to show if you have a carbon, usually it's carbon, if you have an atom with 4 electron groups around it, then if you put 2 of them in the plane, then you have one that points out and one that points back. So that's what they're trying to show here. They're saying these 2 are in the plane, and then you have one that points out, they use the wedge, and one that points back, that's the hash line, the dash line. Does that make sense? So if you see that, that's what they're trying to show. Every carbon with 4 bonds will be tetrahedral like this. Okay. All right. So, and you have this table. Okay, so you are going to have to look at an atom in a Lewis structure, and you're going to have to decide what the bond angle is. So this has 4 electron groups. We have 2 lone pairs and 2 bonds. This tricked people a lot last year. If you have 4 electron groups, that's 109.5. Sometimes people ignore the lone pairs and say, oh, that's linear. That's not linear. This is tetrahedral. We have 2 lone pairs, 2 bonds, that's 109.5, the bond angles. Okay. And so the carbons here would also have bond angles of 109.5. So that's one of the ALEKS topics. You have to look at the molecule and decide the bond angles. And we're going to talk about, sometimes we don't always draw the lone pairs. So even if the lone pairs are not shown on the oxygen, they're still there. They're still affecting the shape of the molecule. So watch out for those. Okay, the last thing we're going to talk about is these chemical groups. So you have this on your table. So we'll just go through. This is a methyl group. If we have a CH3, that's called methyl. If we have a CH2, that's usually in the middle of the carbon chain. We have something on both sides. That's called a methylene group. If we have OH at the end, that's called a hydroxy group. If we have a carbon double bonded to an oxygen in the middle of a chain, that's called a carbonyl. And then if we have nitrogen bonded to 2 hydrogens with a lone pair dots and an amino group. So you're going to have to pick out the right elements in a Lewis structure and say, oh, they'll say find the methylene group. So you have to go through and find the C and the 2 H's or something like that. Does that make sense? Okay. All right, that is all for today. You should work on either Lab 13, Chapter 11, Alex. You now have your signature assignment. If you're all caught up with everything, you could work on practicing for the final. So there's lots to do. You could also, if you're all caught up, you could do the pre-lab for Lab 5. That's another thing you can do.
Oh, look like a scroll.